if you see this diagram, in this case, we have a pulley there. But in our experiment, we're not using a pulley. You see that this thread or the string is wound on the axle, right? We don't have a pulley here, so this string is gonna hang here. And the end of this string is having a weight hanger where we're gonna put a weight. What this weight is going to do, there is a certain height of the weight of the hanger, but when we're gonna put the weight on this hanger, what is gonna happen? Because of this gravitational force, it's going to pull the string. When the string is pulled, what is going to happen to the flywheel? The flywheel is going to rotate because the string is going to unmount, right? So this is how we're going to perform the experiment. So what we're going to do, we're going to find out this height, the height of the lowest point and the point where we're going to let the weight move downward, or where we're going to let the weight free, right? From that point and the lowest point, we're going to measure that height, and we're also going to measure the time taken by this weight to get to the lowest point when we release it, right? This is the procedure of the experiment. Get it? I've also shared a link on the text box. You can also see that as well. Somebody from some university have uploaded his lab report about the experiment. So that is only for a reference, right? You can see that as a reference as well. You get it? That in our case, we don't have this pulley. The thread is wound the same way. The one end is fixed at the axle and the other end is having a hanger. When this thread is wound on the axle, there is some level of this hanger. We're gonna put the weight. That weight is gonna let this hanger go down to the lowest possible point. We're gonna measure the height between those 2 points and the time taken by the weight to get to that point. And we know, don't forget that we know that weight, the amount of the weight we're putting on the hanger, right? This is how we perform the experiment. Do you have any question about it?
Sir, I have a question.
What?
Sir, why we not use pulley here?
Why do we do what?
Sir, we cannot use pulley. Why?
We're not using a pulley because it's not in our apparatus. There is another possibility of that of this apparatus. When we're using a pulley, then we're adding a little bit of the friction in our procedure or operation.
Okay, sir. Thank you.
But because we
काइंडली
have
सर
these type of
सर
hello,
काइंडली थोड़ा बड़ा कर दें ये पता ही नहीं चल रहा सर
get it?
यस सर दिस इज गुड सर
In our case, this pulley is not available. This thread is hanging straight down. It's not running over a pulley, right? Do you have any question about the procedure? All right, if you don't have any question, then we move to the observations. These are the set of observations, right? देखो जब थ्रेड अनवाउंड होगा बिकॉज ऑफ द वेट, तो क्या कैसे अनवाउंड होता है? अनवाउंड होगा तो एक्सल को रोटेट भी करवाएगा वो, होता है ऐसे। एक्सेल पे वाउंड, जब एक्सेल पे वाउंड होगा, वाउंड होने के बाद ही वो नीचे हैंग करेगा ना। हाँ लेकिन अनबाउंड तो होगा ना वो, अनबाउंड कैसे करेंगे? जहाँ अनबाउंड है वहां पे पैरेलल तो नहीं, वहां पे तो 90 डिग्री पे है जहाँ पे बाउंड हुआ हुआ है। तो दैट्स व्हाट आई एम सेइंग, राइट? अच्छा, इस केस में ऐसा नहीं होता है, द थ्रेड, द टाइप ऑफ द थ्रेड वी आर यूजिंग, इट्स गोना have enough friction to let the axle rotate. ठीक है?
So in case अगर हम वो पुली यूज करते हैं तो पुली की भी इनर्शिया काउंट होगा ना?
पुली से, पुली जो है सिर्फ वो हमारे ऑपरेशन को स्मूथ कर रही है, बट स्टिल वी आर एडिंग सम फ्रिक्शन इन दैट, बिकॉज हमारे केस में पुली अवेलेबल ही नहीं है, तो वी आर नॉट गोना टॉक अबाउट इट, राइट?
तो
Okay. Okay, now you see that this is the load which is being put on the hanger, which is P, right? 1.25, 2.75, 2.25, so on. And this is the height of that level, right? Every time you have a different value of the height, right? But it's not a big difference. It's probably because of the stretch in the string when you're adding the load, right? So these are the heights. And time for fall is this: T1, T2, T3. Three number of readings are taken for a time, and then the average is taken, which is 34.75 of these three readings, right? Similarly, we're going to have time for 10 revolution. ठीक है? जो हम नंबर ऑफ वाउंड दे रहे हैं, नंबर ऑफ वाइंडिंग्स दे रहे हैं, वो दोज आर 10, ठीक? उनके अनवाइंड होने के लिए वी नीड द सेम नंबर ऑफ आरपीएम्स, तो इट शुड ऑलमोस्ट बी सेम। ये जो रीडिंग्स हैं यहाँ पे, दे शुड बी सेम, राइट? बट अनफॉर्चुनेटली दीज रीडिंग्स आर नॉट सेम। Get it? So we took the time for 10 revolution here, which does not matter if we're not taking that time, right? It we can pick any one of them and it should be same, but you know, because of the human error, like we won't be able to take the time right at the time when it hits a lower level. So that difference is because of that reading not being taken exactly, right? So we can use any one of the times, either it's for 10 revolution or the time of fall. It remains the same. It's very little difference between the two times. So these are the set of
तो
observations
ये
we're gonna use.
user,
Yes.
how do we actually measure these two different times, like small t and capital T?
Come again. I couldn't get you.
How do we measure the time with small denoted by
Using a
small t and
stopwatch.
denoted by capital T?
Using a stopwatch.
But I meant to say that what is the difference between them?
The difference between them is that this is the first time is the time when the hanger is going to hit the lowest level, right? And the other one is the time of 10 RPMs of the flywheel, because we're giving the thread 10 wound. So that's why we're taking the time for 10 RPM. It should be same, right? You see that there is a very little difference between the two times. So we can pick any one of them.
Thank you, sir.
All right. And at the end, we have the set of formulas we're going to use there, right? So these are the formula. This is angular velocity. And then we have the moment of inertia about a-axis. This is the experimental one. And then we have another moment of inertia about b-axis. I told you that there are two axes, right? So we're going to take the moment above. And the last one is the moment of inertia, that is the theoretical value. And these are few parameters given that you should know. The weight of the flywheel is 68.5 pounds. The radius of the flywheel is 6.7 inch. The radius of the spindle or the axle is zero point 0.5 inch. And G in inch per square second is 386.22. So make sure that you're using all the same unit and convert them all in the standard units first, right? And then you try to find out the values. So this is how we're going to perform the experiment, and using these formulas we're going to find out theoretical and experimental value of the moment of inertia, right? And that's it for the experiment. Now you're gonna pick the observation of your own choice, and you're gonna find out the theoretical and experimental value of moment of inertia of a flywheel, and you're gonna find out the percentage error, and you know what is the formula of the percentage error. That is theoretical value minus experimental value divided by theoretical value. The whole thing is multiplied with 100 is gonna give us the percentage error, and you're gonna find that out, and that's it. I'm waiting for that now.
theoretical एक ही होगी along either axis.
Yes, theoretical एक ही value है, ठीक है, and that is for a axis. Yes.
सर जो ओमेगा का फॉर्मूला है वो इधर 2 पाई h/t मेंशन है, तो ये तो यूनिट्स के साथ मैच ही नहीं कर रहा।
क्या कह रहे हो?
सर मैं कह रहा हूँ जो ओमेगा का फॉर्मूला है 2 पाई h/t, ये मैच ही नहीं कर रहा, मतलब डायमेंशनली इनकरेक्ट है, क्योंकि इस तरफ तो 2 पाई h/t का यूनिट बन जाएगा मीटर पर सेकंड, और ओमेगा का होता है रेडियन पर सेकंड या। क्या कर रहा था? नहीं, वो एंगुलर वेलोसिटी का यूनिट नहीं
हाँ जी, बताओ
डायमेंशन।
बताओ, somebody was asking the question, बताओ क्या है?
सर जो ओमेगा का फॉर्मूला है 2 पाई h/t, ये डायमेंशनली इनकरेक्ट नहीं है, क्योंकि एक साइड पे तो रेडियन पर सेकंड है, दूसरे साइड पे मीटर पर सेकंड आ रहा है।
नहीं तो ओमेगा होता क्या है? 2 pi r/t. It's the same formula. ठीक है,
सर
टू
वो
बाई एन
मैंने एक पास्ट लैब रिपोर्ट भी कंसल्ट की थी, तो उसमें 2 पाई n/t लिखा हुआ है, मतलब h की जगह नंबर ऑफ टर्न्स है।
let me see, 2 pi h/t. 2 pi n नहीं है यार, ये h नहीं है. This is 2 pi n/t. And there's a number of revolutions. The number of revolutions are 10. H नहीं आएगा यहाँ पे.
यस सर।
H is not going to give us the angle of the velocity.
Sir, I believe the manual is considering the h to be the exactly the same value which is winded along the axis, meaning it will be equal to the height that the mass hanger falls will be equal to the height which is wounded around along the axis maybe.
अच्छा, हम ये कह सकते हैं, देखो जितने उसके आरपीएम्स हैं उतनी ही हाइट है, जितना एंगुलर, जितना ओवर द पेरिफेरी ऑफ द फ्लाईव्हील जितना ट्रेवल हुआ है ना, वही दैट एग्जैक्टली इज इक्वल टू एज, तो उसने इनडायरेक्टली उसको एज ही कंसीडर कर लिया।